So for 6.2, we're going to talk, 6.2 and 6.3 are very similar sections. So we're going to talk about trig functions and the unit circle approach, and then kind of say, well, what if it wasn't a unit circle? Could we kind of force it to become a unit circle? So the first thing we want to say is we're going to start off, and again, this may not be exactly how some of you remember it. I actually don't remember learning it this way. I learned it the SOHCAHTOA way, where many of you learned sine is opposite over hypotenuse and everything like that. So I'm going to talk about that as well. But right now we're just going to talk about this kind of the base way, and then we'll kind of be more advanced by the end of 6.2. So it says, let t be a real number and let p equal x comma y. Be a point on the unit circle that corresponds to t, okay? So we're going to say that the sine of t corresponds to the y value of that point p, the cosine of t corresponds to x, the tangent of t corresponds to the ratio y over x, the cosecant is 1 over y, which is the reciprocal of sine, the secant is 1 over x, which is the reciprocal of cosine, and then the tangent of t, the cotangent of t, which is x over y, which is the reciprocal of tangent. So I really want you guys to kind of see the connection between these two. Oops. So there's definitely some kind of connection here, and it's just all about a connection through reciprocals. They are not inverses. They are not the inverse operation. They are reciprocals. So we'll talk about that, and sine functions, cosine functions, tangent functions, so on and so on. They're basically ratios of something over something. So what angle is associated with those ratios is what trig is basically about. So we're going to come down here and we're going to kind of start off with a weaker version of the unit circle. We don't have very much information about it. So I just labeled kind of ones we might know, right? Since it's a unit circle, we know that if we go from here to here, that has a distance of 1 because it's a unit, right? 1 unit, unit circle. And so that's how I got my x coordinate to be 1 and my y coordinate to be 0. If we go from here to here, right? Our distance from there to there would be 0, 1 as a point. If we go from here to here, for some reason the name, geez, I'm just having a moment. I can't remember the name of when it ends on one of those sides. It'll come to me eventually. It's just escaping my memory right now. So each one of these, 0, pi halves, pi, 3 pi halves, and 2 pi. So I wrote them in radians. If you guys want to write them in degrees, you could say that this is 90 degrees, this is 180 degrees, this is 270 degrees, this is 360 degrees, this is 0 degrees. Okay, so I just like to work with both. So you want your mind to be able to hop back and forth between radians and degrees all the time. It just makes everything so much easier for you. So for this first problem we're going to look at, we're going to pretend that the point P goes -1/2 for an x value and a y value of square root 3 over 2. Okay, so let's see. If the distance is 1, that means that like right about here is -1/2, right? So that means I'm going to be here. And square root of 3 divided by 2, let's see. Second function, square root of 3 divided by 2, that's about 1.22. So that means we're going to go down over here. So second function, square root of 3. Oops. Yeah, so we get, there you go. I accidentally did it wrong. I knew something was wrong because I got bigger than 1. So we get about 0.866. So this would be about 0.866. So we're just kind of going to draw this point. We're going to call this our point P. And it is, oops, no. It's a positive. I'm sorry. I just realized. So this is a positive 3/2. So here's -1/2 for my x value. So we're going to go up to right about here. And then this value here is about 0.866. So this point right here, point P, will be -1/2 comma square root 3 over 2, okay? So what we want to do is we want to identify all of our sine, cosine, all of our trig functions, okay? So we're just going to look up here, and again, pretty much for the rest of your life in math, you have to associate the sine function with the y coordinate and the cosine function with the x coordinate. That's in general for the rest of your life in math, in Euclidean geometry. You have to associate the sine function with the cosine function, okay? I'm sorry, the sine function with y and the cosine function with x. So we're going to just say that literally the sine of t is worth the y coordinate. So this would become square root 3 over 2. The cosine of t is literally the x coordinate, which is negative 1 over 2. Okay, so this angle right here, okay, this angle has this ratio when you draw this triangle like this. Okay, so this has a height of square root 3 over 2 and a length of negative 1/2, right? And now if you do a squared plus b squared equals c squared, you'll get negative 1/2 squared plus square root 3 over 2 squared equals 1, because this is a unit circle, right? So then this would become 1/4 plus 3/4 equals 1, so 1 equals 1. So it actually holds, it checks out, which it has to. And again, in general, the trig functions are associated with right triangles. We can do other things with them that aren't right, but in general, it all comes back to right triangles because of where they're kind of generated from this Pythagorean theorem, right? So whenever you want to find a distance, right, you can always use the Pythagorean theorem and right triangles. That's kind of where, well, that's not kind of, that is where the distance formula comes from. So all I did was I just said, okay, let me plug in my x, let me plug in my y. Now we have tangent of t. So the tangent of t, we see up here says y over the x. So in this case, my y is square root 3 over 2 divided by my x, which is negative 1/2. But that's actually square root 3 over 2 times negative 2 over 1. Cancel, cancel. So we're just going to get negative square root of 3. Okay? So hopefully you guys are okay so far. Now you guys take a minute to do these other ones. Now I might have to write it up here a little bit because cosecant is going to be 2 over the square root of 3, the flip, the reciprocal of that, right? Now the thing is, in pre-calculus, you're not allowed to leave radicals in the denominator. In calculus, you are, because you've already proven to your, you've proven yourself, you've proven that you know how to rationalize the denominators. But in pre-calculus, all the answers will always be rational denominators. So you have to multiply this by square root of 3 over 3, and we end up with 2 square roots of 3 over 3, and that would be your cosecant. Let's do this one right here. This would be, oh, this one will clean up nice. This one will just be negative 2 over 1, which is just negative 2. Not too bad. Now cotangent is going to be negative 1/2 over square root 3 over 2, but that's going to be negative 1/2 times 2 over the square root of 3. Cancel, cancel. So this will be negative 1 over the square root of 3. So as you notice, I could have just turned negative square root of 3 and did the reciprocal, and I would have gotten here, but this is not acceptable in this class. So this becomes negative square root of 3 over 3. I just rationalized the denominator once again. This is something you should have learned in a previous class. If not, definitely talk to me about it. Something quick we can fix. And it's not too bad. It's just all of your answers have to be written in this form or you'll constantly get them wrong. So I will mark you wrong as well. So make sure that you do that. It's a little ticky-tack thing that you shouldn't miss. So just let me know if you're struggling with it. Now, since I'm kind of getting the feel of the unit circle, the cosine, remember, is associated with the x coordinate. So they're saying when you have 7 pi radians, what would your x coordinate be? So what I'm going to do is I'm going to come here and I'm going to run around the unit circle. So here's 1 pi, oops, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. So I'm right here at this location. So that means that my x coordinate would be negative 1. So we get negative 1. And that's all there is to it. It's not so bad. It's not so bad. We just need to understand how the unit circle works. We need to understand what the trig functions are, what they represent. In terms of right now, we're going to keep expanding what they mean. Just kind of a way to think about it is trig functions are basically saying the ratio of the side lengths of a triangle that's generated from a certain angle, okay? So as you could see, I did that over here with this problem here. I drew my point and then I drew my right triangle, and that kind of justified why they're the x and y coordinates. And then the sign is those ratios. So if you notice, these are all ratios, right? Some of them are over 1, but they're all ratios. So these are things that we like to keep track of in trigonometry and kind of memorize. All right, so these are very specific ones that we're doing now. And again, you guys hopefully remember the 45, 45, 90 and the 30, 60, 90. So let's kind of see where the rest of the unit circle comes from, okay? Or I guess the one that we memorize. So what about 45 degrees? Well, I'm going to take a look at 45 degrees. And I'm going to draw my little triangle right here, right? So I know that this is my x and y coordinate, okay? So if I just take this triangle now, I'm going to kind of write it bigger just so we can look at it. So that's my theta, and we know that that is 45 degrees, okay? So what I also know is that this distance has to be x, and this distance has to be y, because that's the coordinate xy, right? And it lands right here on the corner of my unit circle. So what I'm going to do now is I'm going to say, what about the Pythagorean theorem? Since I'm working with a right triangle, right? That's a right triangle. I know that x squared plus y squared equals 1, because this is a unit circle, so I know the radius has to be 1. Now here's the rub. I actually know that x has to equal y, because the way angles work, if this is 45 degrees, okay, the way 45 degrees works, that means that this angle must also be 45 degrees if this is 90 degrees, right? Because they all have to add up to 180 in the type of math we do in this class. So, and this is a radius of 1 right there, right? So now here's the thing. We now know that x has to be y, because if this is 45 degrees and this is 45 degrees, then the side lengths across them have to be the same if you're dealing with a triangle. So we're going to come up with x squared plus y. Oops, I'm going to change y squared to be also worth x squared, because I could have done it to make everything worth y squared. Because remember, y equals x and x equals y. They have to be the same. So I just chose to use the x's. So this would be 2x squared equals 1. So this would be x squared equals 1/2. Square root both sides. So then x is equal. Now again, technically in trig, you're allowed to say things are minus, because you could say you're going in the leftward direction or the negative direction. So we're going to just for now, though, count this as the positive square root of 1 over 2. But this, if you split it, is really square root 1 over square root 2. So this is 1 over the square root of 2. But remember, I told you you can't leave that in this class. So this becomes square root of 2 over 2. Okay. Now, remember, I told you that x and y are the same. So then that means that y is also square root 2 over 2. So we now have right here, my coordinates would now be square root 2 over 2, comma, square root 2 over 2. So now if I asked you for sine, cosine, tangent, of this, so I could say sine of pi over 4, no, let's do 45 degrees because that's what I was doing, 45 degrees, that would be, what is it, the x coordinate or the y coordinate? It's the y coordinate, so it would be square root 2 over 2. Cosine of 45 degrees would be square root 2 over 2. Now tangent of 45 degrees would be 1, because if you take square root 2 over 2 divided by square root 2 over 2, you get 1. Now we can come over here and we can say cosecant of 45 degrees would be 2 over the square root of 2, but that would just be 2 square roots of 2 over 2, so you would end up with square root 2. The secant of 45 degrees would be also square root 2, and the cotangent of 45 degrees would also be 1. So 45 degrees is a really, really nice set of angles, because everything cleans up so good with 45 degrees because both side lengths are the same. We could do something similar with 60 degrees. So let's say that we had 60 degrees. It kind of still looks like 45, huh? Let's do 60 degrees. You know what? I'll do it inside the unit circle. That'll help me draw it better. So now this is 60 degrees. So I'm going to take this and I'm going to make it bigger so we can read it. Okay, so that's 60 degrees, but then that means that's 30 degrees and this is 90 degrees, right? So what I can do now is I know that this side length is 1, right? Let's call this my side length x, right? Because we're here. So this is x comma y again. So this is x and this is y. And once again, I know that x squared plus y squared is equal to 1. But you know what, let me leave a little room. There's a little, it's a little tricky right here. So what I'm going to do is I'm going to draw a matching triangle that is also 60 degrees and 30 degrees, right? And then that means that's x, that means that's 1, all right? And we still don't know either value, right? But we know the height is still y. Now here's the thing, here's kind of the weird part. This, because of the way I drew it, doesn't that really mean I just drew an equilateral triangle, right? Because this is now 60, this is now 60, and this is now 60, right? Because the 30 and the 30 are 60 as well. But equilateral triangles all have equal angles, so they must also have equal side lengths. So that means this has to equal 1, this has to equal 1, and this has to equal 1. But we know that this is 2 x's, right? Because of these two guys right here. So that might help us. So then we know that x is equal to 1/2, right? See how that kind of, it happened out of nowhere. But we built an equilateral triangle to help us find this side length. So this side length right here is 1/2. Now here's the thing, if that side length is 1/2, then I know that x squared plus y squared is equal to 1, because this is a unit circle, right? So now I'm back here again. So now we have 1/2 squared plus y squared equals 1. So this will be 1/4 plus y squared equals 1. So then y squared is equal to what, 3/4 when I subtract 1/4. And then we're gonna square root both sides. And we'll end up with y is equal to the square root of 3 over 2. So we now have y. So now we have x and we have y. We can go back up here. We have our x is 1/2. We have our y is square root 3 over 2. And that's where the 30, 60, 90 triangle comes from, right? So you now know the side across from 30 degrees is 1/2. You know the side across from 60 degrees is square root 3 over 2. From this kind of, I guess it's like a trick of turning a 30, 60, 90 into a 60, 60, 60 triangle. Kind of sneaky. So now I can answer all the trig functions. I can say the sine of 60 degrees is equal to, let's see, sine is associated with y, square root 3 over 2. Cosine is associated with x, so I could say 1/2. Tangent, 60 degrees, is y over x. It's square root 3 over 2 divided by 1/2. So this will be similar to what happened last time. This will become square root 3 over 2 times 2 over 1. So this will become square root 3, okay? And then you guys can do the same for secant or for cosecant, secant, and cotangent. And you'll see how things work from there. But I just wanted to show you guys where the 30, 60, 90 triangle came from and where the 45, 45, 90 values came from for the unit circle, okay? You should memorize those, but again, some teachers let you use a unit circle note card. I don't let you do that. If we were taking the class in a classroom, you would have to memorize all these. Since it's at home, you can probably do it. But what I want to do now And again, just because I was using 60 degrees, I could have just as easily used pi over 3, pi over 3, pi over 3, because I could work in radians just as easily as I could work in degrees. So what I want to do real quick is just give you guys the unit circle. And these are the ones you should know by heart. Okay, so let's look at the first one. So let's say 30. Okay, so 30 degrees. This would be, let's say, pi sixth. Here's 45 degrees, and here's 60 degrees. Okay, so this would be pi thirds. This would be pi fourths. Here is pi halves. We already did this one. Here's pi. Here's 3 pi over 2. Here's 2 pi or 0. Okay, so now I'm going to write down these guys as x and y coordinates. Okay, oops. So 60 degrees had the sine of square root 3 over 2 and the x. So 60 degrees had square root 3 over 2 and the x was 1/2. Well, that means that 30 degrees or pi 6 is going to be the flip of that. So it'll be square root 3 over 2 comma 1/2. And then we know this is square root 2 over 2 comma square root 2 over 2. And then this is 0 comma 1. Now here's the thing. You can go into this next quadrant. This would be into quadrant 2. And in quadrant 2, you also have, this would be 5 pi, oops, let me write that. This would be 5 pi over 6, almost 6 pi over 6, which is pi, right? This is 3 pi over 4, and this is 2 pi over 3, okay? So, or, you know, once again, 30, 45, 60, 90, plus another 30, 120, plus another, geez, that's 135, and then that is 150. So I'm just basically showing you that these angles will match. So what we can do over here now, oops, okay, everything will stay the same. So this will be square root 3 over 2 comma 1/2. It matches what's over here. This will become square root 2 over 2 comma square root 2 over 2. And this will become 1/2 comma square root 3 over 2. The only difference now is in this quadrant, in quadrant 2, all the x coordinates are negative. So this is a negative, this is a negative, and this is a negative. Okay, and then you keep going into each quadrant. Now there's a lot of ways to memorize it, but notice all of the measurements, or I should say all of the ratios are the same numbers, they're just rearranged. So what I do is I just memorize the first one. I just memorize that pi over 6 or 30 degrees has a cosine of pi over 6 is equal to square root 3 over 2, and a sine of pi over 6 is worth a 1/2. So I memorize those two, and then anything else, I know it flip-flops. So instead of being 30, if I go to 60, then I know it flip-flops, and now the cosine of pi thirds is 1/2, and the sine of pi thirds would be square root 3 over 2. The x and y coordinates flip. That's kind of a nice relationship between sine and cosine. We don't have to worry about much at pi fourths or 45-degree angles and all the multiples of 45-degree angles because, or integer multiples, I should say, because for all of those guys, it's always square root 2 over 2 and square root 2 over 2, and all you have to memorize is, or figure out, is which quadrant you're in. Okay, so you guys can fill out the rest of the unit circle. I don't think that's too tough. So let me see here. So let's use kind of some thinking we have now. So find the exact value. Oops. Say we have sine of 45 degrees plus the cosine of 60 degrees. So this is something you might be asked to do, but you know that the sine of 45 is the y coordinate, which would be square root 2 over 2, plus cosine of 60 degrees is the x coordinate, which we know is 1/2, right? So this would become square root 2 plus 1 over 2, and that's the best you can do. That's your answer, okay? Now, what if somebody tries to get a little bit fancier and they say, okay, what about secant of 30 degrees times the cotangent of 45 degrees? Well, now that's a little bit weirder. So we know that secant of 30 is associated, remember, we go way back up here. Secant is associated with cosine, okay? It's the reciprocal of cosine, right? So I'm just gonna do the secant, I'm gonna do 1 over the cosine of 30 degrees. Or you know what we can do? What is the cosine of 30 degrees? And we can just turn it upside down. So the cosine of 30 degrees, or pi 6, is square root 3 over 2. So we're going to turn that upside down and do 2 over the square root of 3. Remember, it's the reciprocal. Times 45 degrees, the tangent would be 1, so the cotangent is still 1. So we get 2 over the square root of 3, which is 2 square roots of 3 over 3. Okay? So it's not so bad. Okay, now these are going to be questions you're going to see on the test right here. This next thing is definitely test level questions. Okay, so find the exact value of the 6 trig functions. Okay. Okay. So we're going to give you 210 degrees. So theta, a lot of times they describe angles in terms of theta equals, or they could call it T as well. Like we started off in this section, theta is 210 degrees. So what we need to do, what you always do first, is you find out where 210 degrees is at. Okay. So from here to here is 180. From here to here is another 30. Now that almost looks like 45. So from here to here, I need another 30 degrees, okay? So that's my angle right there. So now I'm gonna draw my triangle from there, okay? And this is, so if I were to draw the unit circle would, oops, you guys get it. I should have drawn the unit circle to start, hold on. Makes it too hard when you don't draw the unit circle right away. So we're gonna start here, oops. So that is 180, but I need to go to 210, so I'm going to go another 30. So what I'm going to do is, here's 30 right here. Okay, so now I draw my triangle, and I take my triangle and I bring it out. This is what I normally do just to make trig make more sense to me. That is now, so basically what we're saying is we are now allowed to associate the trig functions with a 30-degree angle, right? Because this is the actual angle, right? This, maybe I should do it in green. This angle here is 210, but all the ratios that are built from that triangle are really going to be associated with 30 degrees, right? Or pi 6, all right? So what I did is I drew my triangle. I kind of made it larger so we can work with it. Now the thing is I know right here that my X and Y coordinates are related to the 30-degree angle. So all I do is I go up to my unit circle and it's square root 3 over 2 and 1/2. So I'm just going to put square root 3 over 2 comma 1/2. And all I have to figure out is which one's negative. Well, if we're in quadrant 3, they're both negative. Okay. So then when I go to do my trig functions, I now have my X coordinate is square root 3 over 2 negative, and my Y coordinate is negative 1/2. Now, you really can't have negative lengths, okay? So we're just kind of using this to remind ourselves. You really can't have negative legs of a triangle, but in trigonometry, they let you talk about it that way. So it's just to remind myself of these negative values, to remind myself that I'm in this quadrant. So I'm gonna do the sine of theta, or the sine of t. In our case, is 210. Okay, and the Y coordinate associated with that will be negative 1/2. The cosine of 210, or the X coordinate, would be negative square root 3 over 2. And now the tangent coordinate of 210 degrees is now worth, let's see here, negative 1/2 divided by square root 3 over 2. So I can multiply by the reciprocal right away. So this would become 1 over the square root of 3, which would be square root of 3 over 3, and the negatives cancel. So tangent is actually positive because a negative divided by a negative is positive, okay? Now let's keep going. Let's go with, what's the next one? Cosecant of 210 degrees. So that would be then -2, and secant of 210 degrees is associated with this guy. Remember, these are the reciprocals, and then cotangent of 210 degrees. So the cotangent of that. So what we're going to do here is this would become -2 over square root of 3, which is -2 square root of 3 over 3. And then cotangent would actually become cosine negative square root 3 over 2 times the reciprocal of -2 over 1, because it's division. And then we would get negative, and a negative is a positive square root 3. So hopefully I didn't make any silly mistakes. You know, double check it. I'm kind of doing all this stuff, talking and writing and moving the screen. I think these are all good. I'm just using on the user. If you see any silly mistakes, always let me know. But that's basically a big part of that. There's one more thing I want to talk about. Let me see here. There was one more. Let me find it in my notes real quick. Sorry about that, you guys. I accidentally closed one of my pages. Okay, so that's a pretty standard test question, by the way, you guys. Let me find this other one from 6. So now you can find any angles associated with 30-60 or 30-60 90s or 45-45 90s, because now we know each of them. So basically, I could ask you to find the exact value of anything now. I could say find exact value, and I could say cosine of 5 pi over 4. Or I could ask you to find the sine of 135 degrees. Or I could ask you to find the sine of negative pi over 4. I could ask you to do any of these. I'll even throw in a tangent. Tangent of 315. And basically what I would recommend is always just drawing a little quick unit circle and finding out where you are. So 5 pi fourths, that's a little bit past 4 pi fourths, right? Because 4 pi fourths is pi. So I'm actually right, oops, wrong drawing. So here is pi, and now I want to go one more fourth, another pi fourth, so that'd be right there. So I'm right here. So that means I'm at a 45-degree angle, right? Or pi over 4. So this is coterminal with pi over 4. So that means that the cosine of 5 pi over 4 is where square root 2 over 2, because it's associated with the 45-degree angle, but or the triangle. But what I have to come up with is it positive or negative? Well, in quadrant 3, we know that the x-coordinate is negative. The sine, just once again, I'm going to draw my little quick unit circle. And then sine of 135 degrees, well, there's 90, there's 135, so it's right there. But now when I draw my triangle, I got a 45, or I have a 45-degree angle again. So now I have this guy. And now I know that the sine of 135 degrees is going to match this 45-degree angle's ratios right here, right? So let's see here. Is my sine my x or my y coordinate? Remember, sine is associated with the y coordinate. So in quadrant 2, the y coordinate is positive, so we get square root 2 over 2. We could do this one real quick. I think you guys are getting the hang of it, hopefully. This one, negative pi fourths, that would be here, right? Because that's the negative angle of 45 degrees, or negative pi fourths. So I'm going to take my little, oops, drew it wrong. So we got that, that's 45 degrees. I drew it bad, but you get the idea. That's 45 degrees once again. But in this quadrant, my sine is negative, so we know that the sine of negative pi over 4, my y coordinate is worth negative square root 2 over 2. Now, tangent is nice when you're dealing with 45 degrees. So we're just going to go around. So here is 180, here's 270, and then another 45 degrees would put us right here. But we know tangent is y over x, but in this quadrant, my y is negative square root 2 over 2, and my x is positive square root 2 over 2. So we get negative 1. So these are all variations of 45. You could do the same thing. I just chose to use 45 because they're quicker. But you could do the same exact thing with 60 degrees and 30 degrees and things like that. So I just wanted to show you guys that now that you know your unit circle for 30 degrees, 60 degrees, and so on, you can kind of mess with a lot more stuff. Now, I want to add this little theorem at the very end here. This is a test question as well, but I mean, I just want to show you guys. So what if it's not a unit circle, okay? If it's not a unit circle, then what we can do now is we can shift to theta, and we can say that the sine of theta is worth y divided by the radius. So you can adjust. So if the radius is ever bigger than 1 and you're no longer working with the unit circle, you can now divide. The theorem basically gives us the ability to just say, well, it'll still match, but we have to divide by the radius to make everything clean up, okay? So what we're gonna do is we're gonna write all these down now. Instead of for t, we're gonna work with theta. Tangent is r, is y over x, and x obviously cannot equal 0. Cosecant theta, remember theta is just a way to talk about an angle, is now r over y. Y obviously cannot equal 0. Secant of theta is equal to r over x. Once again, x cannot equal 0. And then cotangent of theta is this ratio of x over y, and y, obviously y cannot equal 0. So basically, this is a way that we can now deal with, we can still find similar relationships in the ratios. So let's say we have our unit circle, and then let's say we draw a bigger circle with a different radius of like 2, let's say, and this has a radius of 1. So we can now adjust it. So we can adjust everything, all right? So here's how you do that. Let's say that we have find, again, this is a test question. Find the exact value of the 6 trig functions of an angle theta if 4 comma negative 3, the point 4 comma negative 3 is a point on its terminal side in standard position. So this is pretty straightforward. You're going to see these all the time. The first thing you always do is you graph 4 comma negative 3. So you want to see what type of circle you're dealing with. So I'm going to graph this, and I'm going to draw a circle. And now this point is going to be on this circle, but the circle is no longer a unit circle. We're going to go over 4. We're going to go over 4 and down 3. Okay, so we're going to over 4. So 1, 2, 3, 4, and then down 3. It's kind of a bad drawing. Let me do this again. 1, 2, 3. One, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so we're going to go over 4, 1, 2, 3, 4, and we're going to go down 3 and put a point. And what they're now telling us is the circle is going to go, I can't draw too well, but you guys get the idea. So right there somewhere. Okay, so we're at the point 4, -3. Okay, and this is the angle. So we started here. So whatever angle is associated with this, right? However, you guys know that when we go to draw our triangle, we draw it to here. Right? So we have this triangle drawn here. Even though this is the angle, where it ends is what matters to us. Where the angle ends is what we do. So in this formula, you notice in the theorem, it states that we have to find r. So the first thing we need to do is we need to find our radius, okay? So we're gonna do x squared plus y squared is equal to r squared, right? Because that's the formula for a circle. Okay, so that's basically your standard form of any circle is x squared plus y squared equals, I'll write this over here, formula for a circle centered at 0, 0. So they said in standard position and everything like that. So we know that x is worth 4, so 16 plus 9 is equal to r squared. So then we have 25 is equal to r squared. So then we know r is equal to 5. So we needed this, so we're good. So now, if I want to find my 6 trig functions, all I have to do is do sine of theta, cosine of theta, tangent of theta. Let's see here, cosecant of theta, secant of theta, and cotan of theta. Good news is that I don't believe have any square roots, so we're not going to have to do any rationalizing the denominator. So according to the theorem, you can still use everything you did. Sine is associated with y, but to adjust for the fact that it's not a unit circle, we divide by the radius of this new circle, which is 5. So I'm just going to take y, which is in this case -3. And you know what, let me draw this triangle over here. Oops. Okay, so we know that this has a distance of 4 here. And again, it's not really a -3, but it just helps me remember, okay? So we're gonna take and for this angle, whatever this angle theta is right here, okay? Whatever this is associated with, it's going to produce these ratios. Now, sine, they say, is the y coordinate divided by the radius, which is 5. Cosine is the x coordinate divided by the radius. And then tangent, if we look up here, it says is y over x. So y is worth -3 over x, which is worth 4, okay? So y over x, -3. Now this will be the reciprocal, -5 over 3. This will be the reciprocal, 5 over 4. And this will be the reciprocal, 4 over 3 with a negative. Now let's just make sure. In this quadrant, in quadrant 4, so we're in quadrant 4. We're in quadrant 4. So in quadrant 4, x is positive and y is negative. So anything associated with the y coordinate will be negative, and anything associated with the x coordinate will be positive. That's why sine is negative and tangent is negative, because tangent is basically sine over cosine or y over x. Cosecant is just the reciprocal, and cotan is just the reciprocal of tangent. But notice cosine and secant are both positive because x is positive, and obviously the radius is always positive because it's a radius. So this is a pretty standard test question where I need you guys to notice something. We never actually found theta. We don't care about theta. We never found it. We were able to find the 6 trig functions, the ratios of the sides of the triangle that would be built from this angle. We were able to find it without actually knowing the angle. So that's something that's kind of important that you want to take away from this, is that oftentimes trig is really nice because you can do a lot of work without knowing the actual angle. You can still find the relationship that that angle would create in the trig functions. Okay, so this is another test question. Make sure you guys ask me for help on any of these. But that's going to do it for 6.2, and I will see you in the next meeting.